Bonjour à tous. Good morning, everybody. Buenos dias todo el mundo. Today we want to take a look at this CSEC question. Question B. It reads, Figure 2 shows the schematic diagram of a step-up transformer. The ratio of the primary to secondary windings is 1 to 2. Assume that the transformer is 100% efficient. Calculate the I secondary voltage to the primary current. And we have it that the primary voltage right here is 10 volts. It gives us a load resistance, and that's 10 ohms, and the turns ratio, which is 1 to 2. So let's go ahead and write those down. So we have Vp to be 10 volts. We have RL to be 10 ohms. We have turns ratio to be 1 to 2. The question asked us to find the secondary voltage and the primary current. So these are the two things that we have to find: secondary voltage and primary current. Alright, remember the formula that I told you I want you to remember in the previous video, and that's Vp over Vs is equal to Np over Ns, which is equal to Is over Ip. When you're trying to find a variable, you need two of these, the working combinations. Now let's try to find Vs, and we're going to use this one since Vs is in it, and we're going to use this one since we have the numbers. Now Vs is equal to Vp over Vs equals to Np over Ns. What is Vp? Vp is 10 volts divided by Vs, since that's what we're trying to find, equals to 1 over 2. Now let's go ahead and highlight Vs, since that's what we're trying to find. Now at this point we are going to cross multiply. Alright, so we have 10 times 2, and that's equal to 20, equals Vs times 1, which is the same thing, so you have Vs. So Vs is equal to 20 volts. So now we have Vs, and that should make it easier to solve for the primary current. Alright, now for the primary current. It is IP, that's what we're going to find. Alright, remember, in order to find VIP, you will use IS over IP for this formula along with one of the other two. I'm going to use the voltage. But since we don't have IS, we'll have to solve for IS first. And here is how we do that. If you look at this diagram, you'll realize that this is a complete circuit, right? You have resistance right here. We just solved for the secondary voltage. So we have voltage and resistance, and that brings Ohm's law into perspective. Now let's go back to the next slide. Now, before we find IP, we will find IS. The circuit looks like this. We know that the output voltage is Vs, and we know that the resistance is 10 ohms. Now look at this. VIR. Now we're trying to find the secondary current. It is equal to V over R. But it is in this circuit, the secondary half of the transformer, and so we'll call this Vs. What is Vs equal to? Vs is equal to 20 volts divided by 10 ohms, which is equal to 2 amperes. So Is is equal to 2 amperes. Is is equal to 2 amperes. Now, IP. The formula is Vp over Vs is equal to Is over IP. What is Vp? Vp is 10 volts. What is Vs? 20 volts. That is equal to Is, which is 2 amperes, divided by IP that we're trying to find. Now let's cross multiply. 10 times IP is 10 IP. 20 times 2 is 40. Remember, in order to remove the 10 from the front of IP, we will divide by 10 and do the same thing to the next side. So that cancels that, and that into that goes 4 times. So IP is equal to 4 amperes. And remember what was said from the beginning. You could have a clear view of where this is going. Remember that if a transformer steps down the voltage, it automatically steps up the current. And if the transformer steps down the current, it steps up the voltage.